Welcome back to Chapter 6 of MA 1103 Business Mathematics 1. I am Renovia Simanjuntak and we will continue with the subchapter 6.2, which we will discuss about the number of elements in a set. So sometimes we encounter problems where we have to count or we have to find the number of elements in a particular set. Yeah. So those kind of problems are called the counting problems, and it is part of a field of study in mathematics which is called the Combinatorics. Okay, so what is the number of elements in a finite set? Yeah, so that's just the result of counting of the elements in the set, right? Okay, so how to denote that number of elements? We use this notation, yeah, n of a, where a is a set. So let's see one example. So first of all, if we have the set A, C, and D, the set B, which consists of B, E, F, and T, and then of course here we know that the number of elements in the set A is just 3, yeah, 1, 2, 3, yeah, and then the number of elements in the set B is 4, and if we add these two numbers, it will be 7. Yeah, on the other hand, if we see the union of A and B, yeah, you can take union of these two sets, it will be the same with this set here, yeah, all right. And then if we take the number of elements in the union, it will be equal to 7, yeah. So in this case, the number of element in A union B is the same with the sum of number of elements in A and the number of elements in B, yeah. And that happens when the sets are disjoint, yeah. You can see there the set A and the set B are disjoint sets, yeah. So when we have disjoint sets, the number of elements of the union is the same with the sum of the number of element of each set. Okay, but what if the two sets are not disjoint? Yeah, what if they have a non-empty intersection? So in general, we have this formula, yeah. So the number of elements in the union of A and B will be the sum of the number of elements in A, the number of elements in B, minus the number of elements in the intersection, yeah. So you can imagine that we cannot count, yeah, the elements in the intersection twice, so we have to subtract one of them, yeah. So that's why we have this formula. Okay, let's see one example, yeah. If we have 100 coffee drinkers, and then we have 70 of them take sugar, 60 of them take cream, and 50 of them take both sugar and cream, yeah. And the question is, how many coffee drinkers take sugar or cream with their coffee? Yeah, so if we have this notation for the sets, yeah, U is the universal set, A is the coffee drinkers who take sugar, and B is the set of coffee drinkers who take cream. And of course, the answer of that question will be what? Will be the number of elements in what? In A or B, yeah? Or we can use the notation of union. So this will be the number of element in A union B. And of course, from the previous formula, we can have this is equal to NA plus NB minus N of A intersection B. And this is equal to 70 plus 60 minus 50, and it is equal to 80 people. Okay, so that's one example. What about if we have 3 sets instead of just 2 sets? What is the number of elements in the unions of those 3 sets? Yeah, so we can have this formula. So basically we just add or we sum all the number of elements in A, B, and C, and then we subtract with the number of elements of intersection of 2 sets. Yeah, so there are A intersection B, A intersection C, and B intersection C, and then we add with the number of element of intersection of 3 sets, which is the A intersection B intersection C. Okay, so in this example we have 3 sets. Yeah, why 3 sets? Because here we have 3 magazines. Yeah, and the manufacturer advertises the cosmetic products in these 3 magazines. Yeah, Allure, Cosmopolitan, and Ladies Home Journal. Yeah, and then in a survey of 500 customers, yeah, they have this data. Yeah, so how many learn from just 1 magazines, how many learns the product from 2 magazines, and how many learn the product from 3 magazines. So here the first question is, how many of the customers saw the manufacturer's advertisement in at least 1 magazine? Yeah, so if we give notation for each of the set here, so let A, yeah, B, X, yeah, where X learns from Allure, yeah, and then B is the set of the person in the survey when it learns from Cosmopolitan, and then C is the set of people learn the advertisement from Ladies Home Journal. Yeah, so of course in here, if we want to know how many customers saw the manufacturer advertisement in at least 1 of the magazine, so it's in either A, B, or C, or 2 of them or 3 of them. Yeah, so of course we want to know the N of A union B union C, and then from the previous formula it is the same with NA plus NB plus NC minus N of A intersection B minus N A intersection C minus N of B intersection C plus N of A intersection B intersection C. Yeah, and you have all the data there. Yeah, so NA is what? 180 plus 200 plus 192, and then we move to minus of 84 minus 52 minus 64, and then plus 38, and of course you can count the end result. Okay, that's the first question. What about the second question here? So how many customers saw the manufacturer's advertisement in exactly 1 magazine? So exactly 1. Yeah, so how to count that? Yeah, so let's think about it and we will discuss this later. Okay, so that's the topics from 6.2, yeah, which is about the number of elements in the set. Thank you all for your attention, and I will see you again in the next video. in the next subchapter. Have a good day.